All right, module 6.2, multiplying polynomials. Quick little vocab. Binomial is a polynomial with just two terms. So when we look at our first example here, we're going to multiply, and I'm going to show you two different ways to do this. Some of you will like one way, and some of you will like the other. You do not need to do both ways, but I do ask that whichever way works for your brain, that you use that method continuously. So looking at this first example, this is a binomial times a trinomial. Two terms times three terms. So the first way I'm going to show you is using the box method. This is kind of like using that old school multiplication table type idea. So we're going to use a box method, which means we're going to have kind of a box. We're going to put this one along this side, and it doesn't matter which way, but this is x. It's a plus 2, and across the top I'm going to go 1 minus 4x plus 2x squared. And then I'm going to do it like we did those old school multiplication tables. So x times 1 is x. Let me grab a different colored marker so that we can maybe emphasize the difference. X times negative 4x. Now, because we are multiplying, the powers should change. So this is saying 1 times negative 4 is negative 4. X times x is x squared. Then we have x times 2x squared. So that's just 1 times 2 is 2. A power of 1 times a power of 2, we just add the powers, so that's just 3. Remembering your rules of exponents. Then we're going to go to the next one. 2 times 1 is 2. 2 times negative 4x is negative 8x. And 2 times 2x squared is 4x squared. Now, if you notice, we have some like terms. If we look here, we have some x's and some x squareds. We're going to group those together, and we're going to write this in order. So what has the highest power up there? The 2x cubed. So our polynomial is 2x cubed. Negative 4x squared plus 4x squared, that's just 0x squared, so we don't need to write those in. But I'm going to do it just so that people can see that it's there. 1x minus 8x is negative 7x, and then a plus 2. If this helps you, leave the 0x squared in there. If not, you can rewrite that as 2x cubed minus 7x plus 2. Now, if you're the type of kid that checks your answers and stuff, nobody ever puts the 0x squared, but it's not necessarily wrong if you do. So this right here would be our final answer. I'm going to do the exact same problem, but I'm going to do it using the distributed method so that you can see another way. Some of you, this is going to resonate, and this is how you're going to do all the problems. Some of you are like, oh, that's just too much, so I need to do this way. So I'm just simply writing the problem down, and I'm going to distribute. This is just like using kind of FOIL, but we have to go over 3 times. So x times 1 is x. X times negative 4 is negative 4x squared. And then x times 2x squared is positive 2x cubed. And then I'm going to go back through and write the other way, or multiply everything by the 2. So I distributed the x through, and I distribute the 2. So 2 times 1 is 2. I'm going to put it over here. 2 times negative 4x is negative 8x. Notice as I'm writing this, I'm writing it underneath because I still have to combine my like terms. 2 times 2x squared is a positive 4x squared. Now, I add my two sets together, and I have 2 minus 7x. These cancel, plus that 2x cubed, because negative 4x squared plus 4x squared is 0x squared. I'm going to flip this around so it's in standard form. 2x cubed minus 7x plus 2. Notice, we get the same answer. Some people's brains work one way, others another way. We just want to make sure that we're covering all our bases. Okay, so I have another example up here. And it asks us to find the volume of a rectangular prism. So we're going to find the the volume of a rectangular prism that is x plus 3 units long, x plus 2 units wide, and x units high. Volume is length times width times height. So what that means is to find this volume, I'm going to take my length, x plus 3, and I'm going to multiply it times my width, x plus 2, and times my height. I have 3 things to multiply together here. When you're multiplying, it doesn't necessarily matter the order. I would, and it's just me, multiplying by x is really easy, so I always like to save it to the end. So I'm going to multiply these together first. Some of you remember the acronym FOIL. First terms, outside terms, inside terms, last terms. Some of you like to use that box method. Some like to use the distributive. I happen to think everybody likes or can use the box method. So I'm going to quickly set that up. Notice this time I put the first one across the top and the second one down, so it doesn't really matter. And we're going to multiply. X times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. I'm going to combine my like terms, and I'm going to write everything else down. So x squared plus 5x plus 6. Now you got to remember, you still have that x out there. Now, because it's just x, there's nothing else, I'm going to go ahead and use that distributive property. So x times x squared is x cubed. X times 5x is 5x squared. And x times 6 is 6x. And remember, please, 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 as I almost forgot, that's the volume. So volume equals, V equals. The last little thing we need to talk about with multiplying is polynomial identities. So this is a mathematical relationship equating one polynomial quantity to another. What we want to do here is verify. They're already telling us that they're equal, but we need to verify that that's really true before we use it. And notice, there's not a lot of numbers up there. It's mostly variables. So I have an x plus a squared minus x minus a squared, and that's supposed to equal 4ax. Well, there's really nothing to do on the right side, so we're going to use the left side, and we're going to expand things out. So x plus a squared, that means x plus a times x plus a. So again, we can use that box method, or for those of you that are like, I'm so over the box method, go ahead and use that distributive property. X times x is x squared. X times a is ax. A times x is ax, alphabetical order. A times a is a squared. Combining our like terms, we get x squared plus ax, excuse me, that's not plus ax. That's plus 2ax plus a squared, because I have 2 of them. Now, I need to actually FOIL this out. I know that that subtraction thing is there. I'm going to kind of ignore it just for a minute. I need to multiply x minus a times x minus a. So again, I'm going to use this little box method. X times x is x squared. X times negative a is negative ax. A times x is negative ax. Negative a times negative a is a positive a squared. So combine like terms. X squared minus 2ax plus a squared. Now, they're telling me that it is equal to 4ax. And we're showing that. So don't say, oh, no, it's not equal, because they're asking you to verify that it is, which means it really is true. You're just showing that it does equal truth by doing the math. This negative here has to get distributed in here to each one of these. And I'm going to rewrite them under here. So under my x squared here, I'm going to write that negative x squared, because this is going back to our subtracting polynomials. This is a positive 2ax, and this is minus ax squared. When I combine these, x squared minus x squared is nothing. 2ax plus 2ax is 4ax. A squared minus a squared is nothing. And they said, wait a minute, that's supposed to be 4ax. So yeah, they're equal. So now you've verified and you've shown this really does work. So we can actually use it later on. Take good notes. Write them down.